Good morning, everyone. Now we're going to start the next session. The topic is energy systems, monitoring, reporting, and verification of GHG emission reduction. The speaker is Mr. Amit Anand. He is the CEO of Carbon Check India Private Limited. He has over 16 years of experience in the field of carbon market in different capacities. During these 16 years, he has worked as consultant for development of CDM projects as well as validator verifier of similar projects. He is also a qualified lead assessor and internal technical reviewer for offset projects under CDM, PCS, Gold Standard, and Social Carbon. He has been actively involved in validation, verification, and internal technical reviewer for more than 300 offset projects in this field. So with this, sir, I hand over the session to you. Thank you. So can you hear me?
Yeah, I can.
So, sir, you will share the PPT or I should share?
You should share the PPT if it's possible.
So can you see it now?
Yeah. Okay. So, will you be handling the slides as well, right?
Yes, sir.
Okay. Thank you. Good morning, everyone. Good morning to all the participants, and good morning, good afternoon, wherever in the world you are. It's a privilege to be speaking to all of you on in this innovative training program on energy systems and carbon neutrality. I have been already introduced. My name is Amit Anand, and I am the CEO of Carbon Check India Private Limited. And today I'll be discussing on monitoring, reporting, and verification requirement for energy system projects with regards to their GHG emission reduction. So, yeah, can we go to the next slide, please? Hello.
Yes, sir. One second.
Yeah. Yeah, so briefly during my presentation, during my lecture, I will cover briefly these topics, a brief introduction about MRV, its history, why is MRV required, what exactly is MRV, then what kinds of different types of MRV are there, then key principles involved in MRV. Then we will discuss specifically about MRV of mitigation action because my presentation deals with MRV of energy systems resulting in GHG emission reduction. So we will discuss that slightly in details in the chapter on MRV of mitigation action, and then we will take different aspects of MRVs that we will discuss on monitoring, we will discuss on reporting, we will discuss on verifications, and then I was not sure whether we had to have these small questions or workshops at them. So I have just put in a few questions. If it's needed, we can go through that as well. Yeah, next slide, please. So with regards to MRV, we'll have to first understand the history of the MRV. So the term MRV first appeared in the context of climate change mitigation policy as a part of Bali Action Plan, with special focus for measurable, reportable, and verifiable, nationally appropriate mitigation commitment or actions. And it was stated that they should be supported and enabled by technology, financing, and capacity building in a measurable, reportable, and verifiable manner. So basically, in Bali Action Plan 2007, it was decided that we have to have some procedures in place and to measure, report, and verify the different commitments and the different targets the different host countries have undertaken as a pledge to mitigate climate change. And it was also decided that they would be supported and through technology transfer, through financing of implementation of such activities, and also through capacity building that will be undertaken from time to time. But it was also and in Bali Convention, it so happened that the nature of obligations or not the nature of MRV was defined explicitly. So how will we measure, what will be the commitments, what will be the actions, how the supports will come, how the transfer of knowledge will happen. All these modalities were not finalized during the uh, Bali Action Plan. But then most recently under Paris Agreement, it was completely agreed that all the countries will provide emissions data and track progress against commitments. And so a basic structure of MRV was finally agreed upon in Paris Agreement. Next slide. So in Paris Agreement, it was also decided that MRVs will become a very significant component in tracking, improving the implementation of mitigation goals and policies articulated under countries' national determined contributions. So it was Paris Agreement which led the way for finalization of what will be reported in MRV, how the MRVs will look like, what will the monitoring procedure, what will be the frequency of verification, what will be the format of reporting, how we will report, the modalities of also, as discussed, in strengthening the capacities of different parties, different actors, different players who will be involved in this entire process. So all this was discussed during the Paris Convention. Can we go to the next slide, please? So now the next question comes is, okay, yes, MRV was, the concept of MRV was discussed and the details are finalized during Paris Convention, but why are MRVs so important? And one thing that we have to understand is that in terms of, if we're talking about mitigation of climate change, if you're talking about taking mitigation actions or devising policies, so a robust MRV system is a backbone of all these mitigation actions. It is also a backbone of carbon pricing mechanism. You can talk about any carbon pricing mechanism in the world. You can talk about carbon tax, which is an upcoming, which various countries are trying to come up with their internal carbon tax mechanism. South Africa already has come up with the carbon tax mechanism. Similarly, Chile also has come up with the carbon tax mechanism. Then a cap and trade mechanism, that is like European Union's emission trading scheme, or China has implemented a pilot emission trading scheme in the host countries. So China's ETS, or the normal GHG mitigation programs that we all hear about, like clean development mechanism, voluntary emission reduction mechanism, various standards like VERA, gold standard. So all these mechanisms, all these carbon pricing, carbon trading mechanisms extensively use MRV. MRV also plays a very key role in building trust among various stakeholders, and it does so by ensuring the accuracy of the results, transparency, comparability of approaches, and it also provides assurance to different stakeholders by by assuring them that a ton of GHG emission reduction anywhere in the world, say in a country like Thailand, or say in a country like Japan, or say in a country like US, is equivalent to a ton of carbon dioxide reduced in India, Bangladesh, China, Brazil, anywhere in the world. So a ton of carbon dioxide reduced is a ton of carbon dioxide reduced, irrespective of the geographies or the location. So so it provides a standardized approach. It provides every stakeholder, every user, everyone who's involved in the process to compare results. If you follow the same process, if you follow the same approach, if you follow the same data, default emission factors and everything, so the results will be the same irrespective of wherever you are in the world, whatever. So it is not determined by geographies. To a certain extent, it can be, because there are certain factors which will be very intrinsic to that geography. But yes, the results would be very comparable. Can we go to the next slide, please? Yes, MRVs also allow tracking of progress towards different climate change related targets, and it also allows us to steer our mitigation actions towards achievement of those targets. And what I mean by target is that if you are following recent climate debates, the target is to keep the global temperature within 1.5 degrees, and for that, we have to take different actions. Now, different companies and countries are pledging that they will become net carbon zero or carbon neutral by 2030 or by 2070. So these are different targets that different countries, different stakeholders, different bodies have set, and they have to be achieved in a timely manner. And so a proper and a robust MRV ensures that you can track how well you are progressing towards achieving achieving those targets. And yes, it will also help everybody to formalize strategies, to make plans, to come up with other solutions which may be required in order to accelerate or to achieve those targets in time. It also provides information about emission sources and different trends in the market, and also helps in informed decision making and formulating climate change mitigation strategies. Then MRV also guarantees transparency, precision, comparability on climate change information. So, as I said earlier, that MRV process, if it is followed in principle, if it is uh, followed precisely, then it will provide transparent results. It will provide comparable results. The results will be accurate, and those will strengthen the belief of various stakeholders in the system, and it will also strengthen the belief in the results that are being achieved. Can we go to the next slide, please? Yeah. So what exactly is MRV? So MRV basically it encompasses three components: monitoring, reporting, and verification. And these processes are related. They are independent, yes, but they are related. And all these processes, if implemented together, brought together, they are a very good tool for a clear understanding of greenhouse gas emissions and their sources. Regular monitoring of mitigation strategies, and their impacts on effective mitigation of climate change. So if these monitoring, reporting, and verification, the three independent processes, if they are implemented in a proper manner and Then they will provide us with a understanding of different greenhouse gas emissions, their sources, their sinks. It will help us in monitoring our mitigation strategies. It will help us in tracking our achievement of the goals. It will also help us in assessing the impacts of our mitigation actions on climate change. So we will now first discuss about monitoring. So in terms of MRV, measure or monitor, it is interchangeably used, but monitor is basically, it can be used interchangeably, but there are different places where they are used differently. If you are in terms of, if you're using it for a national inventories, then you are also measuring. But if you're talking about very specific projects, then you are first measuring and then monitoring, but these words are used interchangeably. So measure or monitor data and information on emissions, mitigation actions, and support. So it may be measurement and monitoring of data and information on emissions, the mitigation actions and support. This may entail direct physical measurement of GHG emissions, estimating emissions or emission reductions, utilizing activity data and emission factors, calculating changes relevant to sustainable development, and collecting information about support for climate change mitigation. So measurement and monitoring can help you in, first of all, calculating what is the emission level, what is the emission reduction that has been achieved. It can, as I have said earlier as well, it can help you in formulating strategies. It can help you in determining the needs that climate change mitigation action needs support, what kind of support. So it can help you. It can help you in formulating a proper strategy, and that strategy can involve support, mitigation action for at a country level, at an organization level, or even at a project level. Report. So report is by compiling this information in inventories and other standardized formats to make it accessible to a range of users and facilitate public disclosure of information. So reporting is necessary because we want this information to reach out to people under Kyoto Protocol, under recent Glasgow Pact in Paris Agreement. It has already been agreed that every country has to prepare its national communication. We have to send our reports of how every country has decided certain actions of that they will undertake to mitigate climate change, and what their plans are to reduce their carbon footprint or become carbon neutral by whatever timeline they have decided. So it requires that every year or every 2 years, whatever frequency has been agreed upon, a report has to be published, and that report will provide information on what's the GHG intensity of the country, what are the GHG, and what GHG mitigation actions have been undertaken, whether they are on course to meet the target or not. So this reporting allows public disclosure of information, and it also allows different stakeholders involved in the process to actually see the progress. Verify is a periodical review or analysis or independent assessment to establish completeness and reliability. So the verification is done periodic. It is an independent review that can be done by a third party or any accredited party, or it can be an internal review. It helps to ensure accuracy and conformance with any established procedure, and can provide meaningful feedback for future improvement. So verification is a process in which the entire activity that has been undertaken, whatever processes has been followed, whether they were in compliance with the requirements of any standards being followed or any national guidelines being followed or any industry best practices, these are assessed, checked, and then the results are either the results are certified or verified. And this process is important because it reduces bias. It gives a fair representation. So it actually helps in strengthening the belief of all the stakeholders in the process and the results that have been obtained by following the entire process of measurement, reporting, and verification. Can we go to the next slide, please? Can we go to the next slide, please? Yeah. So in this section, we will talk on types of MRV. So basically, there are three types of MRV. There is an MRV of emissions, in which GHG emissions are quantified and their mitigation strategies there. So this is a quantification of emissions at national level, at organization level, and at facility level. Then there is a MRV of mitigation actions, in which there are three components: MRV of GHG effects. In this, changes in emissions due to mitigation actions is monitored, reported, and verified. Then there is an MRV of sustainable development effects, in which there are changes in addition to GHG emission reductions, contribution of project to the society, to local stakeholders, to the people who are impacted by the project. So it is in addition, it is an addition to the GHG emission reduction that is the main objective of the project. So this is mitigation of sustainable development effects. Then it also encompasses progress made towards implementing the mitigation actions. What's the progress of how well the mitigation actions have been implemented. Then there is an MRV of support. So MRV of support is, it encompasses support provided in terms of financial aid, in terms of technology transfer, in terms of training, and then with it also it also has a component in where the evaluation of all the support that has been provided in achieving this GHG mitigation or GHG targets. So whether those supports have been adequate, whether there is a need of further support, what else can be done to strengthen the capacity of the people who are involved in this process. So these are the three basic component types of MRV. Can we go to the next slide, please? Yeah, so MRV of GHG emissions, as I said, MRV of GHG emissions, it involves measuring and monitoring the GHG emissions and removals associated with the activity of entities. It could be done at an organization level, it could be done at a national level, or it could be done at a facility level. The reports are from the results. The results are reported in formats like GHG inventory or national communication report or biannual report, and after undertaking review and verification. An example of this would be national GHG inventories include an account of emissions from a country for a particular period, and that had to be reported as required under United Nations Framework Convention on Climate Change. And it undergoes internal review at the United Nations itself. So the report from countries, similarly for an organization or for a facility, it could be reported under, for a facility, it could be reported under ISO 14064 Part 1. For organization, they could still use ISO 14064-1, or they can still use GHG protocol for organization levels, and they can report these their emissions, their emission intensity, the kind of actions they are taking, the mitigation actions and everything. So there are different standards that can be used, and then the frequency of reporting has to be decided. But in a general term, the frequency of reporting is an annual basis. So yes, there are different formats at which it could be reported. Can we go to the next slide, please? Yes, so MRV of mitigation action. So mitigation action refers to interventions and commitments, including goals, policies, and projects undertaken by a government or any other entity to reduce GHG emissions. So in terms of MRV, we will first time hear the word projects, which is under this action, MRV of mitigation action. So mitigation action is basically, it refers to interventions, any sort of interventions and commitments, or any kind of activity that you undertake. It could be goals, policies, or projects aimed toward reduction of GHG emissions. It involves assessing at an ex ante level or at an ex post level, GHG emission reductions and or sustainable development, effects of policies, projects, and actions, as well as monitoring their implementation progress. So, ex post, ex ante is that you do it in terms of GHG projects. Ex ante is you do it once and it is fixed. It is a value that is fixed for future years as well. And ex post is that a monitoring is done on a regular basis. So that can be done for GHG emission reductions or sustainable development effect, as I said, contribution to environment, contribution to society, livelihood, access to clean energy, access to clean drinking water. All these could be an example of sustainable development benefits. It involves assessing progress towards mitigation goals. While MRV of GHG emissions measure actual emissions, MRV of mitigation actions estimated changes in emissions. So when you talk about MRV of GHG emissions, we are actually measuring what is the emission as a country. If you're saying what is the GHG emission level of a country, which sectors are contributing more GHG emissions, which are the energy intensive sectors, what is the contribution sector wise, per capita wise. So we are talking about in terms of emissions when we're talking about MRV of GHG emissions. But when we are talking about MRV of mitigation actions, then we are talking about actions that have been implemented and how much reduction they have caused to the GHG emission level. So we are talking about it estimates the change in level of emissions and other non-GHG variables. And so non-GHG variables, as I've said, the sustainable development benefits that result from such actions. Can we go to the next slide, please? So MRV of mitigation action, it has three components. So first component is MRV of GHG effects. As I said, if we talk about in terms of a project activity, it is like renewable energy generation. If you are putting up a wind power plant, so in terms you are adding cleaner power to the grid generation mix of the grid, and in terms you are reducing the GHG intensity of per unit of electricity that is being generated. So that is an example of GHG effects. Another example is that if you're implementing energy efficiency project in an industry or in a commercial building, then you are ultimately impacting the reduction of fossil fuel consumption or reduction of electricity use, and which will in turn result in decrease of GHG emissions. MRV of sustainable development effects. Most of the GHG mitigation projects to a certain extent have some impact on the so sustainable development impact, even like installation of a wind power project. It impacts the life of local stakeholders or people living nearby. It generates employment opportunity. It may increase the income. It may increase the standard of living or livelihood of the people staying in the areas nearby. Similarly, if you are implementing improved cook stoves to the rural households in any part of the world, what you are doing is you are actually replacing a traditional 3-stone fire or an inefficient stove, which may in turn have an impact on reduction in the levels of indoor air pollution, and which will have a positive impacts on the positive health benefits of the people who are actually involved in people of the household and people who are involved in the cooking processes. So these are the type of sustainable development effects that the project can have. And MRV of implementation progress. You can, in case of renewable energy program, it would involve monitoring of training conducted, a number of people trained in technical aspects with installation and operation, increase in the share of renewable energy in the current generation mix. So whatever projects that you are implementing, the progress of those implementations and how they have impacted the targets, implementation goals. So this will fall under MRV of implementation progress. So these are basically three types of MRV under mitigation actions. Can we go to the next slide, please? Okay, so MRV of support. MRV of support, as I told you when we were looking at this diagram or that pictorial description. MRV of support, it is focused on monitoring the provision and receipt of financial flows in terms of donations, in terms of aid, which comes from developed countries, which comes from multilateral organizations to least developed countries, to small island countries, or to any developing country also in a very specific sector. So these are receipt of financial flows, technical knowledge, capacity building, and then evaluating the results and impacts of such support with climate finance, technology transfer, and capacity building. So it is basically, as the name suggests, it is a support provided in achieving those GHG reduction targets, and whether those supports have been adequate, whether those supports have helped in achieving those targets. If not, then this MRV can also provide areas, identify gaps, areas for improvement, better management of those entire support activities and processes. An example of this kind of MRV would be developing countries tracking climate change specific finance received through bilateral or multilateral channels. So, yeah, so that's MRV of support. Can we go to the next slide, please? So till now we have briefly discussed about how brief history of MRV, how it came from Bali, then it was finally conceptualized, and all those modalities and procedures were established in Paris. Then why MRV is important, what is actually MRV, then what are the different types of MRV, and what are the objectives of these different types of MRV. Now we will we will discuss about key principles of MRV. So for a monitoring, reporting, and verification process, there are certain principles. The first principle is relevance, and by relevance, we simply mean is that all the GHG sources, GHG sinks, reservoirs, data, methodologies that we use for estimation of GHG emissions, GHG emission reductions, they are appropriate to the need of the intended user. So whatever type of MRV we are trying to follow. So each type of MRV has a methodology, has an approach. So based on the outcome, our approach should be relevant to that outcome, and based on that outcome, we should also determine the relevant GHG sources, sinks, and reservoirs. So if the entire, I would say, data, parameter, methodologies, all these things that are being used in that MRV process should be relevant to the outcome, relevant to the end result. Then the principle of completeness, it means that all the relevant information support. So it means that the entire information should be complete. There should not be any missing information. So if you're talking about a project, if you're talking about a GHG MRV of a project, then yes, in the information about project, what the project is, what the technology is, what is the baseline scenario, what is the project boundary, what are the relevant GHG sources, what are the relevant GHG sinks, what are the what parameters are to be monitored. So all this information should be there, and the information should be complete, because if the information is complete, then the results will not be correct. The results will be incomplete, they will not be correct, and then the results will be of no use to the intended user. So the entire information should be complete. Consistency, as I said in the beginning of the presentation, that MRV allows comparability of the results. So use of consistent information, use of consistent approach is very much necessary if we are to compare the results of the similar activities in different parts of the world, if similar mitigation actions being undertaken in different parts of the world, if we are to compare the results and see the efficacy and effectiveness of such actions, then there should be a consistency in approach. The approach should be consistent. Next slide, please. The other key principle is accuracy. So by accuracy, we mean that our results should be accurate. There, it is a principle which is aimed at minimizing uncertainties, biases. So there should not be any bias. There should not be any uncertainty in the process. Then we come to the principle of transparency. So transparency is that whenever we are doing an MRV process, we want our data sources, we want our information to be transparent. They should be traceable. The idea for the basic idea behind this is that if I have come up with a result and if I provide the same set of information to the other person in any part of the world with same data sources, references, then he or she should be able to arrive at the same result. And that can only happen when we are disclosing our information, when we are very transparent in disclosing the information, the data sources, the assumptions, whatever we have used in achieving the results. So disclose sufficient and appropriate GHG related information to allow intended users to make decisions with reasonable confidence. That is what ISO 14064-2 describes transparency as the principle. Conservativeness. It is a very important principle in terms of MRV. By conservativeness, we simply mean that when we are calculating our GHG emissions or GHG emissions removals or reductions, we should not overestimate anything. So if suppose if we are using a default value, if you're using a default value, and if you are using a project specific value, or suppose if you are using for a project for transportation, if you're using a value of diesel. So the basic hierarchy is that if you're going to use emission factor for diesel or NCB for diesel, the hierarchy is that if you can get a value directly from the fuel supplier, that is the most robust. If not, then you can have it at a national level. If not possible at the national level, then you can go at international default values. So when you are going for international default values, each of these default values have a upper bound value and a lower bound value. So we have to be careful in selecting which values to use. So if you are using it for estimating baseline emissions, then you should use lower bound values. If you are using it for estimation of your project emissions, then you should use upper bound values, because by using such an approach, it will give you a conservative result, which will ultimately ensure that you are not overestimating your GHG emissions, your GHG removals or emission reductions. Yeah, so that is use conservative assumptions, values, and procedures to ensure that reductions of GHG emissions and enhancements of removal are not overestimated. So these are the 6 key principles of MRV: relevance, completeness, consistency, accuracy, transparency, and conservativeness. So these are the 6 guiding principles on which that entire MRV exercise works. Next slide. So now we will discuss about monitoring. So I've taken this definition from glossary of terms from Clean Development Mechanism version 10. But monitoring, it refers to collection and archiving of all relevant data necessary for determining the baseline, measuring anthropogenic GHG emission by sources of greenhouse gases, within the project boundary of a project activity and leakage as applicable. So monitoring basically is exercise of where you collect all the data, gather all the information with regards to the type of activity that is being undertaken, and it should help you, and it should help you in determining the baseline. It should help you in measuring the emission by different GHG sources of a project activity within the project boundary, and it should also help you in measuring the leakages, which can also be called as, in terms of ISO 14064, we can call it as secondary effects, or in terms of GHG protocol, we can also call it as secondary effect leakage. So the idea of monitoring is the same. Next slide, please. So what does monitoring involve? Monitoring involves identification of GHG assessment boundary or project boundary. Now, we are now talking specifically about monitoring of mitigation actions, and in that too, we are specifically now talking about GHG effects, because the topic of my presentation was MRV of energy systems and GHG emission reduction. So now we are discussing specifically about MRV of GHG effects specifically, and in that we're talking about projects. So what does monitoring involve in that sense when you're talking about monitoring of a GHG effect or a project? So first and foremost, it will involve that you define a boundary. There has to be a clear-cut boundary in which that entire GHG estimation or calculation or monitoring or reporting activity will take place. So first and foremost, there should be a identification or determination of GHG assessment boundary or project boundary. The second part is that then within that boundary, you have to identify the GHG baseline sources. What is the first GHG baseline scenario? What is the baseline scenario? Then emission sources corresponding to that baseline scenario. Then what is your project activity? The third point is, what is your project activity? Then what are the emission sources or sinks relevant to your project activity? Then also identification of leakages. Then selecting relevant GHG sources, sinks, and reservoirs for monitoring or estimating GHG emissions and removals. So then quantification of GHG emissions and removals. Then quantification of GHG emission reduction, and then finally managing data quality. So these monitoring typically for in terms of a GHG project, which or a GHG project or energy project will involve these steps, and now I'll try to go through these steps one by one. So can we go to the next slide, please? So first and foremost, I said is the first point was identification or GHG assessment boundary or project boundary. So as I said, the project boundary, it is defined by the definition as in CDM glossary of terms is the physical delineation and or geographical area of the project activity and the specification of GHGs and sources under the control of project participants that are significant and reasonably attributable to the project activity in accordance with the applied methodologies, and where applicable, the applied standardized baselines. So when you talk about GHG boundary, it's a physical delineation, or it could be a geographical area of the project activity under which the GHG sources and sinks can be attributable to the project activity and are also under the control of the project owner. This, in terms of for project boundary, when you are in terms of GHG projects, when you're applying different methodologies, and if you have different type of projects, so each type of project will have a very different methodology, and so the definition of project boundary is provided within the methodology itself. But in a broader terms, the project boundary is a physical area which is under the control of the PP, and in which the GHG significant, in which there are GHG sources which are directly attributable to the project activity, and those are significant sources which are attributable to the project activity. And then, as I said, each methodology, each standardized baseline or tool, they will provide you with a specific definition of project boundary with regards to the specific type of the project. Now we can, in the next coming slides, we'll see few examples of the project boundary. So yeah, can we go to the next slide, please? So in terms of renewable energy project, so you see the purpose of this project activity is to generate electricity through installation of wind turbines and supply electricity to the national grid. So if you see, the main activity is this installation of the wind turbines, then the emission reduction happens by replacement of the electricity in the grid. So the project boundary, as you can see, is the physical installation of wind turbines, the substation, the electric grid, and other power plants that are also connected to the grid. So this entire, all these together will be within the project boundary. All these together will uh, can be called as a project boundary for a renewable energy project, because for such projects, it is said that the physical installation and where emission reduction occurs. So in terms of a renewable energy project, the site of physical installation is where your wind turbines are installed, and the emission reduction actually happens on account of replacement of fossil fuel fired electricity generation from the electricity grid. And other power plants that are also connected to the grid are a part of the electricity grid. So this is the electricity grid where your emission reduction will happen. So in terms of a renewable energy generation project, this your project boundary will include the electricity grid, other power plants that are connected to the grid, and your physical project, your project site, your wind power site, the substation in terms of hydropower project, the hydropower site, the substation, the metering yard. All these along with the grid will be the project boundary for a renewable energy project. Can we go to the next slide, please? So I've taken an example of energy efficiency in buildings. So for energy efficiency project, your project boundary will be the physical place where all these energy efficient interventions are implemented, because actually that is the place where your emission reduction will happen. So in terms of, if you see this methodology AMS2E, which from CDM, which I have used here, that a methodology says that the project boundary for energy efficiency project is the place where all the energy efficient interventions are implemented. So in terms of this project, if you say this is energy efficient building, so there is a natural gas based engine that is supplying electricity to the building. There is a diesel generator set backup. Then all the energy measures installed in the green building, solar PV panels on the rooftop for provision of renewable energy. So all these interventions are at this building site, and all this together will form the project boundary for this kind of a project, energy efficiency project. Can you go to the next slide, please? So this is the fuel switch project, which involves conversion of thermal. So which involves conversion of fuel, which involves switching of the baseline fuel coal by a natural gas, and it also involves slight modification in the combustion system at the brick factory or brick kiln. So for this, the project boundary is defined as the area where this it is the physical location of the brick factory, because this gas is coming from a pipeline, this coal is coming from outside. So these cannot. So these, along with the entire brick factory, is the project boundary. So this methodology AMS 3Z, this defines the project boundary in such a manner that fuel, your facility, all these things will be the physical activity where the project is implemented will be your project boundary. So So in terms of GHG project, identification of project boundary, because an appropriate identification of project boundary will lead to an appropriate identification of relevant GHG sources and sinks. So as I said, in this project, in this case of fuel switch project, the project boundary includes, I think I've said earlier that it does not include, but it includes the coal baseline fuel, it includes the natural gas, the replacement fuel, it includes the brick factory, and then it includes the combustion systems for coal and natural gas. So this entire activity, entire process, because this is the physical site where the interventions are going to be placed for fuel switch, where the fuel is going, and that will have the impact on emission reduction. So that entire all those things combined together will form the project boundary for such a project. Thank you. Can we go to the next slide? So in terms of monitoring, the next most important stage, or one of the most important aspects is identification of baseline scenario. Baseline scenario simply means is that what was the most plausible thing that would have happened in the absence of the project activity. So if we're talking about a wind power project or a hydropower project or a geothermal project or a biomass-based power project, if it is being implemented in India or in any other country, what is the most plausible thing that would have happened if that project was not implemented? So if that project was not implemented, that situation, if this renewable energy intervention will not come up, what will happen? So it will be the continuation of the current practice. It will be the maintenance of status quo. So if a country like India, the electricity would still be generated in the generation mix that we had, which is dominated by thermal power plant. Similarly, it would happen in other parts of the world. So that for energy efficiency project or a fuel switch project, if you're substituting higher carbon intensive fuel with a lower carbon intensive fuel, so suppose the project activity does not come up, so it will the project active, if the fuel switch does not happen, then in that case the project will operate with a higher carbon intensity fuel. In terms of energy efficiency, if you're not putting up energy efficiency measures, then you will continue to use inefficient appliances, or there would so inefficient use of inefficient appliances or use of inefficient technology. That is what is going to be the continuation of the current practice scenario. So that is what your baseline will be in that case. So baseline is nothing but you have to, it can be hypothetical sometimes, but it has to be understood that it is a scenario where we're talking about is, suppose this new GHG mitigation intervention will not happen. What will happen in that case? So as I've given you examples, we can see in further slides as well. Can we go to the next slide? So for a renewable energy project, as I said, this is the baseline scenario that the fossil fuel will be fired. It will supply electricity to the grid. That will result in CO2 emissions. So this is what will continue to happen in case of renewable energy. In case this is what a baseline for a renewable energy project will look like. Can you go to the next slide? So energy efficiency in buildings. So the baseline scenario is consumption of electricity and heat due to one less efficient and or more carbon intensive equipment. And second, if we are there are architectural interventions in the building that in your project activity, then yes, less efficient construction features in buildings. So the baseline scenario is that, as I said, you will continue to use inefficient technologies. There would be use of higher carbon intensive fuels. And if the new building, if you're designing a completely green building and then you are trying to put all the new energy efficient interventions, then in that case, if you're not coming up with a green building, then the existing building will remain, and that will, if it is an energy inefficient building or structure with less energy efficient interventions, architectural interventions, or less smart technical interventions. So yes, that will continue to remain so. So that will be the baseline scenario for energy efficiency in buildings. Can we go to the next slide, please? So fuel switch, as I said, it's fairly simpler. If you're not either completely replacing the higher energy intensive fuel with a lower carbon intensity fuel, then suppose if you're not replacing coal with natural gas, then you will continue to use coal. Because for a factory, for an industry, where these are basically industrial projects. So in that case, those factories, those industries won't stop production. So if you're not replacing, if you're not putting up a GHG mitigation action of replacing a higher intensity fuel with a lower carbon intensive fuel, then the factory will continue to operate on a higher intensive fuel, and that will form your baseline. So as I said, in terms of the example that I gave earlier, is that replacement of coal by natural gas. So if you're not going to bring in natural gas, so coal definitely will be our baseline. So just to summarize, the baseline scenario is a most plausible scenario which would happen in the absence of the project activity. So that is what baseline scenario is. Can we go to the next slide, please? So the next aspect of monitoring is identification of the project scenario. So your project is a renewable. So we take an example of renewable energy project again. So your project is a renewable energy project. You are installing a wind power plant or hydropower plant. So in that case, the crosses signify the things that has been taken out. So in terms of then the fossil fuel will be replaced by renewable energy. That will lead to generation of electricity, and so that will reduce the carbon intensity of the grid. So the project scenario will be displacement of electricity provided to the grid by more GHG intensive means, by installation of new renewable power plants, or retrofitting or replacement or capacity additions of existing renewable power plants. So yeah, it will be replacement of fossil fuel, and it would be so actually, in terms of renewable energy project, the project scenario will be, what we say is that by adding a renewable energy project, you are actually, in a sense, trying to delay the construction of a thermal power plant of a similar capacity that would have come up to augment the generation capacity. So that is a hypothetical situation, because that really will not happen. But that's how we define the project scenario there. So you are actually replacing that kind of fossil fuel forward contribution to the grid by implementing a renewable energy project. So in terms of energy efficiency, if you see, these boxes are slightly not dark; they are slightly light in color. So this signifies that in terms of energy efficient project, your consumption of fossil fuel has decreased, and so based on that, and based on the upgrade and interventions that we put in building, that through implementation of smart features, through implementation of any efficient equipments, energy efficiency, other energy efficiency measures, or implementation of other renewable energy technologies, or different type of sensors and all those things, you have actually reduced the output of CO2. So the consumption of fossil fuel has decreased, and similarly the CO2 emissions have decreased because of implementation of these energy efficient measures. So the project scenario is the upgrade or implementation of energy efficient features in the buildings. So it says consumption of less electricity and heat due to more efficient and use of less carbon intensive equipment and more efficient construction features in the buildings. Yeah. Can we go to the next slide? So fuel switch in brick manufacturing. So the project scenario is brick production using less carbon intensive fuel or biomass in a more efficient facility. So the first example that I gave you, the first slide where project boundary, I gave you that it was a replacement of a higher carbon intensive fuel with a lower carbon intensive fuel, that coal replaced by natural gas. So yes, so if you see the fossil fuel quantity of fossil fuel that has decreased, and so has the CO2 emissions. So this sums up your project scenario is that either you have switched over to a less carbon intensive fuel, or if you want to have a further reduction in GHG emission, you can switch over to completely renewable source of energy, biomass as well, and then there could be other upgrades. Upgrades would involve conversion of maybe combustion systems in the brick industry for the type of fuel that you are trying to burn. So that could be an upgrade, and then you could change the fuel mix, and that could result in your reduced CO2 emissions from your production. So that is what a project scenario is. So project scenario basically is the scenario that you are actually going. Is your project activity? What is your project activity, and how does it impact the baseline? And that will give you the project scenario. So suppose as we are on this slide, I'll take an example. So your project activity, so your baseline was use of coal. So in terms of project, you're going to replace coal, completely replace, or you can have coal as a backup. So you will buy natural gas. So if you still have that coal, provision of firing coal in your project, in terms of if you foresee a disruption in natural gas supply, or there could be an irregularity in natural gas supply. So then the project scenario is that you will reduce the consumption of coal. You will not completely phase out coal, but you will reduce the consumption of coal, which is a higher carbon intensive fuel, and thus that will result in reduction of GHG emissions compared to your baseline level. But you may choose to completely do away with coal, and in that case in that case you will have to completely overhaul your combustion system. So that will be an upgrade to your facility, and then you are completely shifting to a new fuel. So then you will be completely replacing coal, and that will lead to GHG emission reduction. So that exactly is your project scenario. Can we go to the next slide? Leakages, as I said, leakage in terms of GHG protocol, or in terms of ISO 14064, it is also defined as secondary effect. So leakage is basically, it is a secondary effect of a project activity which happens mostly outside the project boundary, and which is not within the control of the project owner. And an example could be, suppose if you are planning to implement a biomass based power project in any area, and you have a power plant of say X capacity, and then you require certain amount of biomass for that, and then you're going to source biomass for your project. So there is a situation in which it may so happen that the biomass that you are actually going to source for your project was already being used by people, because it may not be in a very organized manner, but it might be being used by people for their energy needs. So if you are taking away that entire biomass, you may force them to switch over to a carbon intensive fuel, the use of coal, charcoal for cooking, or for whatever their needs. So that is happening outside your project boundary. That's not within your control. But that emission, because the biomass, now they're no longer using biomass, but they will shift to coal or charcoal. That emission is attributable to your project activity. So that is an example of leakage. If we are talking about say energy efficiency project, say suppose if you are replacing a 3-star AC with a 5-star AC, and but that 3-star AC is not out of the system. It goes somewhere. It is still being used. So an energy efficiency program which actually is suppose replacement of incandescent bulb with the LED bulb. So there is a requirement in the program that the bulb should be destroyed. This is simply because to avoid leakages. If the bulb is not destroyed, the bulb will be used somewhere because it will remain in the system. So suppose if a household which was using some other maybe kerosene, it comes to bulb, but then incandescent bulb still has a higher energy consumption as compared to an LED bulb. So that replacement of your that project of your replacement of LED bulb is not resulting in complete replacement of incandescent bulbs. So sorry, the project activity of yours for replacement of incandescent bulbs with LED bulbs is not resulting in complete replacement of those incandescent bulbs. And they will continue to be used. They will be outside your project boundary. But those emissions on the account of use of those higher energy consuming bulbs will be attributable to your project. So that is also an example of leakage. So leakage emissions are classified as emissions which happen outside the project boundary on attributable to your project. In terms of renewable energy projects, we say that there is no leakage, but yes, suppose if you are putting up a wind power plant by using, by transferring of equipment. So suppose if you are transferring equipment from some other project, some other site to this site. So in terms, what is happening at that site, whether their energy demand now for that, they have come up with they are now using a DG set or some other fossil fuel. So that could fossil fuel barred energy source. So that could also result in leakages. But in terms of generally speaking, in terms of renewable energy projects, there is no leakage. So yeah. So now we come to quantification of GHG emissions or removal. So I have briefly tried to give few examples of how to calculate. So for baseline emissions, so baseline emissions are defined as emissions that would have happened in the absence of the GHG mitigation project activity. So first example is for a grid connected renewable energy power project. So your baseline emission would be the amount of electricity that is exported uh, by the project activity multiplied by the grid emission factor, because the baseline is that you would be replacing the equivalent amount of electricity. So the amount of electricity that you are actually exporting to the grid, so that is the net electricity exported to the grid, that will be multiplied by the grid emission factor, that is tons of CO2 per megawatt hour per unit of electricity, and that will give you your baseline emissions. Baseline emissions for fuel switch project activity. For fuel switch project activity, in the baseline will be it will be dependent upon identified baseline scenario, that is the baseline fuel. So whatever fuel that you are replacing, so it will be the amount of fossil fuel consumed in the baseline in the density of the fuel into NCV of the fuel into emission factor of the fuel. That is how you will calculate the baseline emissions. And in terms of fuel switch project also, the amount of fuel that was being consumed in the baseline is based on historical values. So you will have to, when you are going to determine the baseline, suppose you were going in a factory, if coal was being used, if you're going to determine the baseline emission factor, then you will have to have records of previous historical consumption of coal, and typically for a period of 3 to 5 years, so that it gives you it averages out uncertainty or some unforeseen circumstances of so it will it will give you that kind of it will average out, so it will give you a much more realistic figure. And in terms of fuel switch project, you also have to keep into account or when you are estimating the baseline emission, that it is dependent on service level. So the service level cannot increase. So what was the service level in the baseline? The same service level shall be in the project scenario. If there is an increase in service level, then that you cannot get any carbon credits for that increase in service level, because suppose if you're producing say 100 tons of end product, and then your project scenario, if you're going to replace fuel and if you're doing all those overhauls and upgrades, and then probably you increase your capacity to 150 tons, so your emission reductions will not be, you cannot claim, and that will be totally incorrect to claim them for 50 tons, because in terms of fuel switch project, the service level has to be maintained. So that is the formula for baseline emissions for fuel switch project activity. Similarly, baseline emissions for energy efficiency project activity is also dependent upon historical value of energy consumption. What was your historical value of energy consumption over a 3 to 5 year period? And then I've taken an example of electricity. So historical electricity consumption into emission factor for the grid. You can similarly have an historical fuel consumption value. If you are putting in some energy efficient measures which will reduce the consumption of fuel, so you can have for fuel consumption as well those, and similar formula as I presented above for fuel switch, and you can calculate the baseline emissions using this formula. So these are very generic. I've just tried to give you an idea of how baseline emissions are calculated. Can we go to the next slide, please? So project emissions, so these are emissions attributable to the project activity due to its operation, and which are within the control of project owner and within the project boundary. So that's how they are different to leakage, because leakage is outside the project boundary and not within the control, but project emissions are within your project boundary and are also within the control of the project owner. So generally, in terms of renewable energy project, the project emission is considered as zero. There is no project emission. But if you're talking about in terms of a hydropower project with reservoir, then yes, there are project emissions which are also called as reservoir emissions. So for hydropower projects with reservoirs with power density somewhere between 4 Weber per meter square to 10 Weber per meter square, the project emission is calculated as total electricity. It is the project emission is not based on net electricity. It is based on the total electricity that is being produced by the project activity into the default emission factor for reservoir emissions. So the default is provided in the methodology or the tools that you will apply for calculation. Similarly, project emission for fuel switch. So it will be dependent upon the less carbon intensive fuel that you are using. So if you're using natural gas, then the project emission, because natural gas still is a fossil fuel, so then you have to calculate the emission, project emission due to combustion of natural gas in your project activity. So project emission for energy efficiency project is there after, even after installation of energy efficient technology, energy efficient interventions, you're still consuming electricity. So whether it's a reduced quantity, so that will still have some emissions. So I've given that example that project emissions can be calculated as project emission is equal to electricity consumption into CO2 grid emission factor. So these are the three basic examples how we can calculate project emission. Can we go to the next slide? So in terms of finally, now we come to quantification of GHG emission reduction. So emission reduction is a reduction in emission of carbon dioxide or greenhouse gases due to implementation of the project activity. 1 ton of emission reduction represents the reduction of 1 ton of carbon dioxide or its equivalent in other GHG gases. I think so. Emission reduction is I think in this slide you cannot see the formula, but emission reduction ER is equal to baseline emissions minus project emissions minus leakage. In that slide itself, I think the table has overshadowed the equation. If you can just reduce the size of the table somehow, you see there is an equation in the background. Yeah. So emission reduction is equal to baseline emissions minus project emissions minus leakage emissions. So 1 ton of whatever your GHG, the emission reductions due to your implementation of your GHG project activity will be calculated as you can calculate your baseline emissions, then you also calculate the emissions due to your project activity. As I said, like for renewable energy projects, we do not generally have any project emission associated with this until unless there are hydro projects with reservoirs, or to an extent with geothermal projects, there could be some project emissions. So emission reduction will be baseline emissions minus project emissions minus leakage emissions. That will give you an emission reduction. That will be, and all the emission reduction is in terms of tons of carbon dioxide equivalent. So even if it's for different other GHG gases, this is finally converted into tons of carbon dioxide equivalent. So 1 ton of carbon dioxide is your one emission reduction, or is equal to 1 carbon credit. So yeah, can we go to the yeah, so now we come to the last part of monitoring, that is the management of data quality. So it is very important that as a project proponent, as a project owner, you should have some quality control procedures implemented, or some quality management procedures to manage the data and information, to ensure proper flow of information, to ensure proper archival of data, proper maintenance of records. And you should also have some provisions to include to uh, to manage emergency situations, to determine the uncertainty. So it's a responsibility of project owner that they should reduce as far as practical uncertainties related to quantification of GHG emission reduction or removal in sanction. And that reduction in uncertainties can be through implementation of proper data management structure, proper roles and responsibilities, a proper organization structure with well-defined roles and responsibilities, a proper process of collection of data, transferring of data, archival of data, then recording of data, and then proper period for keeping those records. So a monitoring procedure should include the following: purpose of monitoring. What is the purpose of monitoring? Types of data and information to be reported, including units of measurement, origin of the data, your monitoring methodology, including estimation, modeling, measurement, or calculation approaches, monitoring time periods, for what duration you are monitoring the results, monitoring roles and responsibilities, who is responsible for what, and then your information management systems, including the location and retention of stored data, or the period for which the data will be recorded or stored. Because if in case if you're going to get these data and results verified, then you have to have a retention period for records as well, because somebody would like to cross check or see those records after, say, 3 years or 4 years, but you should have a well-defined period for retention of records as well, so that after your project lifetime, you will keep your data for 2 years after your project's lifetime. So in that case, a proper retention period of your records will also be defined. So that is, with that we come to the end of monitoring. Now, can we go to the next slide, please? I think I'll quickly go through because the time is. So reporting is basically what your report should look like. So the title of the project activity, name of the project proponent, the GHG program to which your project subscribes, brief description of your GHG project, including size, location, duration, type of activity, a GHG statement, including GHG emission reduction and removal enhancement in terms of CO2. Your report can also include whether your GHG statement or whether your GHG claim has been validated or verified, type of validation and verification, what is the level of assurance, limited or reasonable, information on your GHG sources and sinks, a statement on the aggregate value of your GHG reductions achieved, a description on GHG baseline, a description on the criteria, procedure, methodologies, good practice guidances that have been used as a basis for your calculation, a statement on uncertainty and how will it affect the GHG quantification and the statement, and the date of the time and the period that has been covered in that report. Can we go to the verification slide, please?
So this one.
Yeah. Okay. So verification, it is a periodic independent evaluation and ex post determination by a validation or verification body or an accredited body of the monitored GHG emission reductions that have occurred as a result of the project activity. So it is a periodic evaluation by a third party independent. You can also have an internal review, but that internal team shall be independent of the process of preparing the monitoring, doing the monitoring and preparing the report. So you can also have an internal review, but it has to be an independent process. Can we go to the next slide? So there are 5 key principles for verification. One of the first principles is impartiality. The purpose of this principle is that there should not be any bias, and this is generally demonstrated through declaration on conflict of interest. That if a verifier is being appointed, he should declare that he has no conflict of interest, he has not worked in any capacity on that project, he has not been involved in that project. So that there is no bias, there is no familiarity, and so that the entire process is an independent process. The second is evidence-based approach. So this is that validation verification engagement employs a rational method for reaching reliable and reproducible verification conclusions, and is based on sufficient and appropriate evidence. So whatever values, whatever data, suppose for electricity generation, if you're using values for electricity generation, are they backed by evidences, whether they are based on invoice, whether they are based on joint meter reading records, or whether they are actually based from from an online platform. So whatever calculation, whatever values are being reported and monitored, they have to be backed by evidence. There should be an evidence trail of generation of data, how those data were generated, how they were captured, how they have been used for the purpose of preparing those reports or calculation of those emissions, GHG emission reduction. So it should have the evidences. So that's an evidence-based approach. In terms of verification, fair presentation, it means that the verifier should very honestly report on whatever shortcomings, findings, conclusions, if there are any issues that have been identified. All this should be transparently and accurately reported. The report also should mention about obstacles encountered during verification process. If there are any unresolved issues, diverging opinions among the client and the verifier, the response. So the report should fairly present some of the entire activity of verification. Documentation, document the validation verification and ensure that it establishes the basis for conclusion and conformity. So whatever the entire audit process, the entire verification process will be properly documented, and it should form the basis for our opinion, for the opinion of verification opinion or certification opinion. Conservativeness, as I have already said, that when assessing comparable alternatives, use a selection that is cautiously moderate, so that overestimation is avoided. So if you are going to use default values, you have to use them very carefully so that you actually reduce the uncertainties. Can we go to the next slide, verification process? Can you go to the next slide, please?
So this one?
Yeah, verification process.
Okay.
So it is a typical flowchart diagram of verification process. So preparation involves signing of a contract, verification contract. During the verification contract or agreement, a level of assurance. First of all, objective of the verification, what will be the scope of verification, what will be the verification criteria, against which standard, which methodology the verification needs to be performed. Then agreement on level of assurance, whether it will be a reasonable assurance or whether it will be a limited level of assurance in terms of GHG projects, in terms of CDM, in terms of other GHG mitigation schemes. The level of assurance is already reasonable, it's not limited. So, but in terms of ISO 14064 or other assurance, other verification assurance, you can, the level of assurance has to be agreed upon between the verifier and the project owner. So that could be limited assurance, that could be reasonable assurance. Then materiality, level of materiality. Materiality is the level of uncertainty that is acceptable, that has to be also agreed upon. Then approach or development. So what will be the verification approach? The verification plan needs to be submitted. The time duration for verification, whether it will be a complete data check or whether it will involve sampling, all these details have to be provided. After that, the verification process is the assessment of GHG data and information. So whatever data, whatever information, whatever values for parameters, different parameters have been used for calculation of GHG emission reduction, those needs to be verified simultaneously. Your information control system, what systems do you have in place, what system project owner has in place to control the information that is flowing. Suppose if it's a renewable energy project, does he have main meter, check meter, does he have a SCADA system, does he have a monitoring system where there is least human interference so that the authenticity of data is more. Then assessment against the verification criteria. If it's a CDM project, then the CDM required rules and requirements are totally complied with. If it's a VCS project, whether VCS rules and requirements have been complied with. If it's a GHG protocol, so whether the calculation, preparation of report has complied with their requirements. So whatever verification criteria has been agreed upon, whether the report complies, whether the monitoring that has been undertaken by the client complies with those criteria, that needs to be assessed. Then evaluation of what your calculation, whatever claims you made that we have received, reduced this much amount of GHG emission reduction. So that evaluation of that GHG assertion, so evaluation of the calculation and everything has to be done, and whether the calculation is correct, whether the value is correct. And as I said, against all those principles, conservative, whether it is transparent, whether it is relevant, accurate, all these. So the entire evaluation of GHG session will happen against those principles, so that all will be checked. And during all this process, your different records will be checked from time to time, and depending upon what stage we are in. And then finally, we will finally the verifier issues a verification statement. Verification statement, he can have based on the kind of assurance or based on the kind of, if he's satisfied with the entire process, and if the way if you're monitoring and the monitoring activities are going Can we
Sir,
go to the
hello,
next
sir.
slide?
I think you
Can we go to the
now.
hello?
Now we can hear you, sir.
Can we go to the next slide, please?
Yes.
So in terms of verification, verifier is defined as a competent and impartial person with responsibility for performing and reporting on a verification, shall be accredited or recognized by the relevant GHG program of accreditation bodies. So GHG program, you are accredited by United Nations Framework Convention on Climate Change if you are a verifier under CDM, or you can be accredited by national accreditation bodies like NABCD in India. A verifier shall comply with principles of independence, ethical conduct, fair presentation, and due professional care. So these are the requirements of verifier, as we spoke about the principles of verification. It's like impartiality, evidence-based approach, fair presentation. So a verifier shall be independent, ethical conduct, fair presentation, and deep professional care. Can we go to the next slide, please? So verification agreement shall contain at the minimum these points. It should cover these points: that scope of verification, objective of verification, criteria against which the verification will take place, the level of materiality, that is the level of uncertainty, how much is the acceptable level of materiality, and then level of assurance, whether it will be a limited level of assurance or a reasonable level of assurance. So this should be actually agreed upon in the verification agreement before the start of verification process. Next slide. So, as I said, level of assurance shall be agreed upon. The level of assurance decides the degree of confidence, the degree of confidence of the verifier in the entire exercise and in making his final conclusion. So reasonable level of assurance is more robust, more confidence, and it is concluded in a positive way. Limited level of assurance is less confidence, and it is the opinion, the verification opinion is concluded in a negative way. For a limited assurance, the verifier generally uses statements such that during our entire activity, we have not come across anything which makes us believe that this system is not robust enough. So this has a negative connotation to it, the opinion. But in terms of reasonable, we say that the verifier says that during our audit process, everything has been analyzed, checked, and we are confident, and we have checked all those data parameters, they are traceable, transparent, and everything. And so we conclude that yes, this is the amount of GHG emission reduction, or this is the GHG emission reduction that has been achieved by the project. So you can see the difference. The verifier affirms that he has checked everything and he's super confident that yes, everything is in order. In the second one, he is trying to say is that during our audit, we have not come across anything, that we have not found anything. It may so happen that if somebody does the audit, he may find something. So we have not found anything which makes us believe that this is not correct. So I'm not saying this is completely correct, but I'm not saying this is incorrect, which makes us believe we have not found anything which makes us doubt or say that this is not correct. So that is the difference between a reasonable opinion under a reasonable level of assurance and opinion under a limited level of assurance. Can we go to the next slide, please? So materiality is, as I said, it is a measure of uncertainty. So it says that it is a concept that individual or an aggregate of errors, omissions, and misrepresentations could affect the GHG assertion and could influence the intended user's decision. So in terms of verification, different standards prescribe different materiality thresholds depending upon the type of the project, the technology, the complexity, and also the amount of GHG emission reductions that is going to be certified or is verified. Sometimes it's also based on the volume of that. So Materiality is decided on objective of the verification, level of assurance, verification criteria, and verification scope. So the broader the scope, it depends upon level of assurance. If it is a limited level of assurance, if there is reasonable level of assurance, when there is a reasonable level of assurance, the materiality threshold can be high. If it is a limited level of assurance, the materiality threshold level can be low. So ultimately, the idea is that suppose if you are doing a project, a renewable energy project, and suppose if you are measuring electricity, so how much material error can be allowed so that it does not make a significant difference on the final judgment. So that comes from the type of the project, the scale of the project, the complexity, and everything. So every parameter, suppose it's being measured by energy meter. So energy meter, then they themselves have an accuracy class, but in terms of CDM, we say 5% materiality is accepted. So yes, suppose it's the total emission reduction is 100 units. So this we say plus minus 5 is that is the uncertainty range that is acceptable for such kind of project. So can we go to the next slide, please? So factors causing materiality, organization boundaries, operational boundaries, activity data, emission factors. So all these factors, all the different stages of monitoring, all will have impact on materiality. Can we go to the next slide, please? So this is an example of a different type of GHG emission removal categories. What is the type of information that will be reviewed or verified? So for combustion, we can have fuel type, quantity of fuel, combustion efficiency, oxidation factor, global warming potential for GHG emitted, calibration of equipment. For processes, we can have emission source, hour of operation, quantity of output, GHGs and their global warming potentials, control equipment efficiency, reliability. Similarly, for imported energy, we have in generating sources, GHG emitted as a function of per unit of electricity generated, transmission and distribution losses. So all these, there are different examples that have been provided that with different kind of removal GHG emission project types. What is the information that needs to be reviewed? Can we go to the next slide, verification statement? So a verification statement, it contains findings overview to the clients. The findings can be in form of corrective action request, clarification request, and forward action request. Corrective action request is a must to do finding that an error has been identified, a mistake has been identified, and that shall be corrected, that needs to be corrected. Clarification is where there is a lack of clarity, there is ambiguity, it's not very clear to the reader, to the end user, intended user of the report, it may create some confusion, so we can seek further clarification. A forward action request is that we foresee a scope of improvement and we want the client to undertake that activity, so we raise a forward action action request that yes, this shall be cross-checked again at the next verification during the next periodic verification. So in that case, a forward action request is raised, which says that the actual GHG information system control requires attention for the next consecutive verification period. So yes, if you see that there is a scope of improvement and it could be done in a better manner for the next verification, so a forward action request is raised. Can we go to the next slide, please? Yeah, so final part, the verification statement. So this is the conclusion of the monitoring, reporting, and verification exercise, the verification statement. The verification statement, it shall be addressed to the intended user of the report, GHG report, GHG session. It should describe the level of assurance, describe the scope, objective, criteria, inside describe whether data and information assertion were hypothetical, projected, or historical in nature, shall be accompanied by responsible parties GHG assertion and shall include the verifier's conclusion on GHG assertion, including any qualifications or limitations. So, yeah. So with that, I conclude. Sorry, I had to rush in the last because I think I was running out of the time. So with that, I conclude my presentation today on monitoring, reporting, and verification for GHG systems. If you have any questions, feel free to ask.
Well done, sir. Please, how can we measure the level of assurance for the project, sir?
Yeah, Mr. Adel, can you just repeat the question again?
How can we measure the level of assurance for the project?
Deliver an assurance for the project.
Yes, sir.
See, if you have a project, I said there are different ways to it. If you are developing a project under a very specific scheme, and the schemes that I said, there are different schemes like there is a clean development mechanism, a scheme by United Nations Framework Convention on Climate Change. Then there are several other voluntary schemes like verified carbon standard. It's by a organization called Vera, which is based in US. Similarly, there is another scheme called Gold Standard for Global Goals. It is a scheme that is supported by a lot of NGOs and is its headquarters is in Switzerland. So either if you are going under different schemes or if you are using it for your carbon neutrality or carbon other purposes, then you can use ISO 14064-1, or for project it is 14064-2. Or if you are still using GHG protocol, so it depends upon what standard are you going to use, and then you can have your project GHG assertion against that standard. So you will have to, as I said in my last section, where that the criteria, verification criteria, against which criteria do you want your project to be assessed. So first, if you decide on that criteria, then based on that criteria, you will first, if you choose a criteria, then you will have to then follow the rules and requirements of that standard or that protocol. And once you all do that, then you can reach out to any, because all these standards, all these protocols have different independent verifiers or independent validation and verification bodies accredited through them. So then through those accreditation bodies, through those validation and verification bodies, you can get your project the GHG assertion verified.
All right, thank you very much, sir.
Welcome.
So there is a query in the chat box. Can you see it, or I should read it for you?
Yeah, I think. Okay. Thank you for the question, Mr. Hafiz. You can start with there is GHG protocol. GHGprotocol.org is the site. There is a link for that in the reference section of my presentation, so you can go to there. You can read there. You can go to the CDM website, UNFCCC, United Nations Framework Convention on Climate Change. The link for that website is also there. And then there are a lot of materials available on the website on the web. You can look for ISO materials which are available on the site. There are but standards will not be available, but the materials are available on the site. And if you require further guidance sometimes, then in my presentation I have the email ID as well. You can reach out to me and probably I can share some useful information with you over email. I hope that answers. Yeah, thank you.
Thank you so much, sir. I think we don't have any more queries. Hello, sir. Can you hear me?
Yeah, okay, thank you.
So now we don't have any queries, I guess. So thank you so
Okay.
much, sir. Now you can leave the meeting.
Okay, so thank you very much for the opportunity, and I hope you have all had a fruitful session. Thank you very much. Have a good day. Bye-bye.
Thank you so much.
Bye-bye, sir.
Now there is we have lunch break, so we'll be back after 45 minutes. Thank you.
Hello, sir. Hello,
Yes.
sir.
Yes.
Please, how do we get those slides and materials being used by the?
We'll be uploading once the lecture, the program gets over. Okay.
Okay. All right. Thank you so much.
Thank you.